Okay, so just finishing off that question. That was what we were looking at, the diagram. So we're going to find the gradient of these two sides and see if they are parallel like they look they are. So we're going to find the gradient of Kj first by putting K and J into our gradient formula. It works out to be minus a half. Then we're going to find the gradient of Hi using H and I in our gradient formula, and it works out to be a half. So we were right, they are parallel. So, but we have to conclude it the right way. So we're going to say, therefore, the gradient of Kj equals the gradient of Hi. Therefore, Kj is parallel to Hi. That is a legal symbol for is parallel to, and you can use it. So don't just get the two gradients and go, yep, they're parallel. Make sure you say that the gradients are equal and then say that. Okay, now you might go, oh, well, that's it. We've got one pair of parallel sides, so it's a trapezium. But you do have to prove that these other two sides, even though we're looking at them going, they don't look parallel, you've still got to do something to show that they're not parallel. Because otherwise, if they are, we have a parallelogram. We would have two pairs of parallel sides. So we're going to have a look at those two sides. So KH, we're going to find the gradient of KH, this one here. And if we sub those numbers in, the gradient of KH works to be 3/4. And then if we look at the other one, JI, we sub those numbers in and its gradient ends up being -3. So we were right, they're not the same, but we have to tell them that. So we have to say the gradient of KH does not equal the gradient of JI. Therefore, KH is not parallel to JI. Then you can say we have one pair of parallel sides, therefore it's a trapezium. Okay, so good luck for your homework.